This is Noah from period 1, and we will be looking at how to graph rational functions. We'll start off by looking at vertical, horizontal, and slant asymptotes along with holes, and we will also find x and y intercepts. So our equation is f of x equals x to x cubed minus 2x squared minus 3x over x squared minus x minus 6. And because the top degree is larger than the bottom, we have no horizontal asymptote. Additionally, because it is only one larger, then we do have a slant asymptote. And to find that, we will use the long division. And we know that x times x squared is x to the cube, and when we subtract that, we get negative x squared plus 3x. And we know that negative 1 times x squared equals negative x squared. And that will give us our y equals mx plus b. We can disregard the remainders because we are only looking for mx plus b. And our equation will be y equals x minus 1. And we will also rewrite it as x equals negative y minus 1 because we are trying to find 2 points. When we plug in 0 for y, we find out that x equals 1. So the point is 1, 0. And when we plug in 0 for x, we find out that y equals negative 1. So the point is 0, negative 1. When looking at vertical asymptotes, we will factor the original equation, and it factors into x times x plus 1 times x minus 3 over x plus 2 times x minus 3. And because these are common factors, we can cross this off because this will later become our whole. And when looking at the denominator, we see that x plus 2, and if we set that to 0, x equals negative 2, and that will be our equation. When writing this in limit notation, we will plug it into our graph, and when we look at the right side of the graph, we see that as x approaches negative 2, it goes to infinity, and as it approaches negative 2 from the left, it goes to negative infinity. And we can write that as x approaches negative 2 from the right, f of x approaches infinity, and as x approaches negative 2 from the left, f of x approaches negative infinity. Also, when we find the wholes, we know that the one we canceled off was x minus 3, so x equals 3. We'll plug this into original, or the simplified equation, which is this, x times x plus 1 over x plus 2, and that makes it 3 times 3 plus 1 over 3 plus 2, and that gives us 12 fifths. So our point will be 3, 12 fifths. Now, when finding the domain, we looked at the bad values, which is negative 2 and 3. And to write that in internal notation, it will be negative infinity, negative 2, union negative 2, 3, union 3, infinity. And to find our x-intercepts, we'll set y equal to 0, so that's what we did here. And we'll multiply both sides by the denominator, and when we do that, it cancels out. So we're just basically solving or setting the numerator equal to 0. And when we solve for that, x equals 0 or x equals negative 1. And that means our point is either 0, 0 or negative 1, 0. To find the y-intercept, we'll replace all the x's with zeros into the simplified equation, which is this. And when we do this, it gives us 0 times 0 plus 1 over 0 plus 2. And when we solve for this, it will be 0 over 2, which is basically 0. So our point is 0, 0. Looking back at the graph, what we know right now is that the slant asymptote crosses the point 0, negative 1, which is 0, negative 1 right here, and also 1, 0, which is right here. So if we draw the line, it will be like this. And also, our vertical asymptote is x equals negative 2, so at negative 2, we can draw our vertical asymptote. And now to find the graph, we will what I did was I chose numbers left of the vertical asymptote and right of the vertical asymptote, the numbers I chose was -3, -4, -5, -6, -1, 0, 1, 2. And to find the y, what I did was you put in your equation and you press trace and you enter the number you want to find. So if I want to find the point at -3, I'll put in -3, and that gives me -6, and I continued this step for all the following numbers. And when I did that, I can graph or put all the points on. So when I put on, I can connect the points, and this will basically give me my graph. I hope you enjoyed.